Baba, with them
Okay,
thing that
let me
word problem. Oh,
share my screen. I don't know why this always does this. I get ready to share my screen and things disappear for some reason. I don't know why.
where's Maureen?
She said she was coming on. Let's see. Session topics.
Where's Mercedes? She
Mercedes supposed to be
tired?
coming on too. Okay. Homework.
Hi, everybody. Good afternoon.
Hello,
Damn,
Mercedes.
you're gonna live long because I was just about to say
She
why you're not in class. I'll send the popo for you.
I'm here.
No
Okay.
excuse. I need to buy everybody a book. It have on the front, it say no excuses.
Exactly.
I should get everybody that for Mother's Day. Make you see it so you can't make no excuse.
Why is, I don't know why this, I don't know
Zoom
why
tired
this
out, Miss Barbara.
happens. No, it doesn't happen in the morning. I mean, the 1 o'clock session. But then when I get on here, it's things seem to disappear.
I'm out for 1 minute. Just a minute. I should be back.
Okay,
Yeah.
let me bring up my topics. And I'm sure you don't see topic schedule, do you?
No.
No. I have share. Okay. I don't know why. This only happens. Let's see. New share. Now, do you see math topic schedule? Yes? No? Everybody's on the,
No, we see your
this
we see
happens in
your
the afternoon. I don't know why on Zoom, and it doesn't happen when I bring them up in the 1 o'clock, the earlier session. And when I come on this one, they seem to disappear.
Yeah.
Okay, new share. And you don't see these topics scheduled.
No.
no, we're just seeing the menu. I don't know if you call it the menu.
Yeah,
but
I know
all-
that's what that happens. I don't know why it happens after I would have shared earlier. They don't, if some, okay, here we go. You see it now?
Yes.
Yeah.
They somehow they disappear and then my folders come up. I don't know
Okay.
why. I've got to find out why that happens. It happens. Okay. Topic schedule. This is what we'll be covering today. We'll go over our homework that we're on binomials and polynomials and factoring. And then we'll factor polynomials and we'll hopefully get to division of polynomials. Okay, now let me go to new share and see if I can bring that. I don't even see what I need. Okay. Let me go down to, I want to do the homework. New share. Maybe I should send Zoom a question on this, why this happens. Now, I know you don't see that, do you, the homework?
No, I don't see any homework.
You need
Okay.
to scroll it up.
Here you go. Now you see it.
Yes.
The thing is, I bring them up just like I do with my early session. So they right there on my screen. But then when I bring them up to share, they seem to disappear. And I've got to find out why. All right, let's do our homework. Now, I did, thanks to Latoya, I got some homework. Because nobody else sent me any. Did anyone send me any and I didn't get it?
I didn't get mine, miss.
And that's another thing, when you say you don't get your homework and I send it to like 5 or 6 people at a time and 5 get it and 1 don't get it. And that's
I got
after
that.
you check your spam?
Yes, miss. I did check it twice. I want to get the GED. I got the GED.
And then when I sent it to you the second time, you got it.
I think you sent it few minutes ago.
After the other class,
class.
you
Yeah.
sent back, you got it, right? So I don't know what's going on with that. But some of you are saying you're not getting the homework, and I send that usually as a separate email. I send regular session, then I send the homework. But if you don't get it, don't let me know the day of the work when we're doing the work. Let me know before so I can send it again. Which means you should be checking it the day of the class, right?
Yes.
And then if you don't get it, let me know so I can forward it to you again. Not
Yes.
not the day that is before it's due. Okay.
Okay, miss.
All right, then I can send it to you again. Okay, let's look at the homework. Now, remember we said we can simplify radicals just like we do regular numbers, right?
Yes, miss.
Now say these. What are factors of 72?
Let me see.
What are some, well, I won't say what are
9
factors.
is 91.
What are, well, I said that's a plural, right? That means you got to give me at least 2 numbers.
Excuse me.
What are factors of 72? Some
Excuse me.
factors.
Some factors. 1, 72 is 1.
Okay, 1 is 72. What are others?
Excuse me. Just my sinus acting up right now.
What are 2 numbers can multiply and get 72? That's what factors are. Numbers that multiply to give
You
the
can
number. So,
multiply 2 by 36 to get 72.
okay, 2 and 36. Those are factors. Any other factors?
8. Now, let me see. Can 18 be 1?
Factors, you have to give me 2, Mercedes. 2
Oh,
numbers
oh.
that multiply to give 72.
18 by 4.
Okay, 18 and 4. And give me one more set of factors. Semicolon here. Another set of factors, just one more.
Thinking. Seven by something.
What about 9
9 by, I'm trying to figure what by 9 again.
and 8,
Okay.
right?
Yes,
Now-
9 by 8.
Now, when you have radicals and you want factors, you want one of your factors to be a perfect square. Now, I sent you a list of perfect squares. Did everybody get them?
No, I didn't get it.
I sent them last week. No, you didn't get it, Latoya?
No,
Well, you got the other work. I think I sent it along with the session.
I didn't see
Did anybody get the list of perfect squares?
Perfect. Perfect.
I sent you a list, a separate list, and it came with the session.
Unless I didn't open all my mails as yet.
Okay, so I sent you a list because I didn't send you a complete list, but I sent you some of the common ones. Like 36, perfect square, 6 times 6, 49, 7 times 7, 16, 4 times 4, right? 121, 11 times 11. I sent you a list.
Well, I
Okay,
would see that if I got it. I don't think
all
so.
right,
I'm not
let me make a note. Some of you said you didn't get it. I'll send it along with the session today. Okay. Perfect squares. And it was a separate flyout along with your other work. All right, it wasn't separate email. It was along with some other work. Now, as I said, when you're simplifying a radical, you want one of your factors to have be a perfect square. So Mercedes, when you gave me 2 and 36, 36 is a perfect square, right?
okay.
Okay, so if you take 70, square root of 72 and factor it into 2 radicals, what do you get?
If I take 72,
No, square root of 72. Just put it here. And I want you to factor this into 2 radicals. What would that be equal to? Now you gave me the factors, so
so oh, I would say 2 by 36.
no, radicals. So that means you got to put them as radicals, right? Got to put them as radicals. So what would you have?
I don't comprehend that part, Miss Barbara.
No. You said the 72 factors are 2 and 36. Square root of 72, it will be radicals. And you said 36, right? And 2. You put that there again. Okay. Just like you factor the number, you can factor the radicals. So this would be square root of 2 times the square root of 36.
That's what you mean, put in the radical?
Yeah, that's what the radical symbol is. This is the radical symbol.
Oh.
Here. Looks like a crooked V. Okay, that's
Okay.
the radical symbol. So square root of 72 is factored to the square root of 2 times square root of 36.
Oh, so when you say radical, that's all I should call it.
Well, that's what it is. This
No,
symbol,
I mean naming it by verbally naming it. That's all.
well,
That's all.
this symbol right here, you see where my cursor is?
Yes.
That's a radical.
Oh.
That's called a radical, right? So we can factor numbers on the radicals just like we do numbers. So square root of 72 is square root of 2 times square root of 36.
So my question was, when you asked me, that's how I should say it to you. Square root of 2 and square root of 36.
Right, when you factor the radical, you'll have, instead of numbers, you'll have radicals, the product of 2 radicals.
Okay.
All right. Questions? Okay, so now all of this would be over 3, right? Because we said square root of 72 over 3. So let's just put this all over 3. Put our 3 here. All right. Okay. Now, What's the square root of 36?
36.
Mercedes, what's the square root of 36?
That would be 6.
Yeah, just like you said when you gave me 2 and 36, right? 6,
Yeah.
because I said it was a perfect square, which means some number by itself gives 36, and that number is 6. So let's put this here. Now, what I'll do is, let me just put the 6 here, right? I'll put the 6 first. And this would be times what? The square root of 2.
Six.
I'm putting
Yeah.
this, I'm just reversing my order here. Okay. And this will be 6 times the square root of 2. Okay. And this will all be over 3. So let me just underline. And over 3. Everybody with me?
Yes, ma'am.
I just reversed the order. I put the square root of 36 first. So square root of 36 is 6 times the square root of 2. Now I have 6 times the square root of 2 divided by 3. Now I have 6 divided by 3 that I can do. What's 6 divided by 3, Mercedes?
That's 2.
That's right. Very good. That's 2. Okay. And so what would my answer be? 2 times what?
2 times 3.
No, 6 over 3 is 2. So what I
Yeah.
have left square root of 2.
It's 2. Yeah.
So I put my square root of 2 here. That's my answer.
Oh, so that's how you do the answer? Oh, that's why I was looking at some you did and I couldn't get it. That's how I don't understand the way you write it. I
Okay.
couldn't understand it.
Yeah. So first of all, you factor the radicals into 2 radicals, just like you factor the numbers into 2 numbers, except they're now radicals. So they factor just like if it was just a number. Square root of 72, square root of 2 times square root of 36. All right. Now, the square root of 36 is 6. So I just reversed the order. Normally, I would put this, let me just do this here. Because normally I put the one that has the perfect square first. So let me do that so it's not confusing. Okay, so I'm putting the square root of 36 times the square root of 2. Okay. Put that back there. Because normally the one that has a perfect square, you put first. Okay, so I put the square root of 2 here. All right, then square root of 36 is 6. Square root of 2 is just square root of 2. So what I have left here is, let me take this little dash out because that was the leftover underline. Okay. All right, so square root of 36 is 6. Square root of 2 remains square root of 2. And of course, in our problem, we had divided by 3. Then 6 divided by 3 is 2. Square root of 2 remains square root of 2. It cannot be factored into anything else other than itself and 1. So that answer would be B, right?
Oh.
Answer B. Any questions on number 1?
Miss, because the 36 is there, doing the square root 12 could not be used.
Square root of 12 is not a perfect square. Remember, I say when you factor in radicals, you want to use a perfect square as one of your factors.
But you
Remember?
could use Yes, but it could use for 72.
12 and 6 are factors of 72, but
Yeah.
12 and 6, neither one are perfect squares. Do you know any number you can multiply by itself and get 12?
Yeah, by itself?
Yes.
No.
Any number you can multiply by itself and get
on it-
6?
No.
Okay, so then those don't work. You need at least one of your factors to be a perfect square.
Oh,
You follow?
yeah.
Maureen?
Yeah,
Maureen, are you talking? Who's talking?
no, I'm not talking.
Maureen is mute.
Okay, Maureen's not on mute.
I mean,
Someone was talking. Okay. Mercedes, did I answer your question?
Yes, please. Thank you.
Yeah, because you said 6 and 12. Those are factors of 72, but neither one of those numbers are perfect squares. Right?
You said neither one of those number.
Are perfect squares.
Okay.
In other words, there's no number you can multiply by itself against 6. There's no number you can multiply by itself and get 12. You got it?
Okay.
Any questions on number 1?
So, Miss, when you reach to the part that we say 6 square with 2 upon 3, you only divide the 3 into the 6 to get your answer.
Well, 6 divided by 3 gives the coefficient. See, 2 is a coefficient of the square root of 2. Just like
Okay.
if you had 2x, 2 would be the coefficient of x. But
Yeah.
now it's a radical. So 6 divided by 3 is 2, and square root of 2 we already had here. So the answer is 2 times square root of 2.
Okay.
Got it?
Yeah, that's sort of new to me, this one.
Okay. Let's take another square root. Okay. Let me take square root and let's put okay. Factor this. Okay, Maureen. Are you with me, Maureen?
yes, Miss Brandon.
Okay, now factor this into 2 radicals, one of which is a perfect square root.
Okay, 25 and 2.
Very good, Maureen. 25 and 2. So we can put here 25. Right? Which is a perfect square root. And we'll put 2. Okay. Now, Maureen, what's the square root of 25?
5.
5. So this becomes what? 5
5.
times the square root of 2.
There is a 2.
Right. Take the 7 out there. And we don't need an underline. So that would be your answer. Square root of 50 equals 5 times the square root of 2. Mercedes, you follow it?
Yes, Miss, I'm following.
Right. Yeah. Because I said to give me 2 radicals that multiply, but one of the radicals is a perfect square, and that's the 25. 25 square root is 5 times 5.
So, Miss, why you have to go down to 5 times 2?
Times square root of 2.
Yeah.
Because if I ask you to simplify this radical, that would be the answer you would give me, 5 times square root of 2.
Okay.
In other words, we can't factor this anymore. 5 is a
Oh.
prime number. It
Okay.
can only be factored into 5 and 1. Square root of 2 is not a perfect square root. So we're simplifying the radical. All right, just like we simplified over here, except we had a division. All right.
Yes, miss.
So you know now, if you have a radical, think of the factors where 1 is a perfect square root. All right.
Okay.
Let's try another one. That's square root of 50. Okay, let's try, let's see, 32. Want to simplify that, Mercedes. What would be my 2 factors that are square roots? What would be the factors, 1 of which is a perfect square? Mercedes, you're on mute.
Oh, I'm sorry. I'm sorry. I was start answering you when I didn't realize. that
You're
I was
on mute. I want you to simplify square root of 32. Think of
So
2 factors, 1 that has a perfect square root.
I was answering you, but I forgot I muted a little bit.
Good
Okay,
So
evening, Miss Barbara.
I'm sorry, someone was saying something?
It's me. I said good evening.
Hello, Audrey. Good to hear you.
Yeah.
Okay, so we were just doing our homework. We're still on number 1. I just want to make sure everybody
that one.
can
Okay,
factor the
I get
radical.
you that one. Hold on.
No, I didn't get anything from you, Audrey.
Because I didn't finish it. I finished the homework at all.
Okay, so the first one we did simplify square root of 72 over 3, and that answer was B. Because square root of 72 factored into 2 and 36. 36 is a perfect square. Now, Audrey, did you get a list of perfect squares I sent you?
I think so.
Okay, because I sent it along with the session.
Yeah, I think yes. And the integers or something.
Yeah, it was like 36 is square root of 36, 6 squared is 36. I gave you a list. I think it went up to maybe 200, number 200.
you repeat, I know I didn't get it. Miss.
I'll send it again. Okay,
Thank you.
Mercedes, square root of
I think I
32
get it.
is
I
what?
was it's 8 and 16. Can work.
What are the factors?
8, 16, 8 and 16.
What's 8 times 16?
No, okay. 2 and 16.
2 and 16. Very good. In other words, 16 and 2 multiply to give you 32, right? So one of these would be 16, and the other one would be 2.
Oh, I got you.
You got me? So what's the answer, Mercedes?
The answer,
Yes, what's the square root of 16?
the square root of 16 is 8.
Square root of 16? 8 times 8 is 64.
No, oh Lord, I'm thinking different. 8 is 16.
Square root of 16?
Oh, you're multiplying when I'm
What number multiplied by itself to give you 16, Mercedes?
8.
8 times 8 is 64.
Okay, 4 fours is 16.
So it would be a 4, right? 4. And then it would be what? 4 times the square root of 2. That would be
Yeah.
the answer.
Oh, no, I'm getting it.
You getting it? The
Yeah.
fact, see, if I just said factors of 32, you could tell me 16 and 2, right? So if I
Yeah.
say factors of the square root of 32 is square root of 16 and square root of 2. Square root of
yes.
16 is a perfect square, the square root of which is 4. And then the square root of 2
Mhm.
cannot be factored into any other radical.
Mhm.
So it's
Yeah,
4 times square root of 2. Got it?
Mhm.
Oh, okay.
That making sense now?
Yes, yes.
Mhm.
Thank
Maureen, are
much.
you okay?
That was Barbara.
Okay.
I get 26. I don't know if that right, Miss Barbara.
You got one?
26.
For what?
B.
For what? You got
That's
20?
number 3 you doing?
No,
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 no.
we still on number 1.
Oh, you still on number 1?
Yes,
Number 1.
we still on number 1. I would just want to make sure everybody understand how to factor radicals.
Oh, what's your
Okay.
number 1? I thought you were number
No, we still on number
all
1.
right, number 1.
We got our answer B for number 1. Now I was just practicing with some radicals
All
to
right.
make
Okay,
sure
I
you,
got that. Okay.
okay. So you understand how to factor radicals, right?
Mhm.
Any questions on factoring radicals?
Just got to practice, miss.
Yes, you factor them just like you do numbers, except they are under the radical symbol.
Okay.
All right, they're under the radical symbol. These are radicals because they have a radical symbol, and that's the radical symbol. All right, let's go to number 2. Audrey, did you do number 2?
Mm-mm. No, I did not.
Latoya, you did number 2. You want to tell us how you did it?
That's 2. F the parameter is 24.
Okay,
That means that
let
thing
me
with the 6.
go.
I don't know if 6, 4,
That's how you're
24,
muted?
6.
Latoya's
I
here.
didn't do number 2, Miss Barbara.
You didn't do number 2?
Which one is it? I
Yes,
can't
you
see
did
it.
do number
Mhm.
2. I'll bring it up on the other screen. You did number 2.
Follow. The value of X
Latoya,
to
you
will
did
be
number 2. I want to know how you did it. Or do you guess?
I'm at number 4.
No, Latoya, did you do number 2?
Yeah, I did.
You did number 2. You sent me the
Yeah, I
right
did
answer.
number 2.
So
Shit.
explain how you did it.
Oh, fuck. I left my paper home.
You don't need your paper.
The
24.
answer is 62 though. X,
So
P, it's a rectangle.
The perimeter.
So the
P is for
area
perimeter.
is 2L
wait a
plus
minute,
2W.
Audrey. Let's hear from Latoya.
No, I'm just saying. I hear you saying P, so I said P is for perimeter.
Yeah, P is for parameters. So tell me what you had, Latoya.
It's 2L plus 2W.
Okay, parameter. Everybody understands parameter formula for a rectangle. 2 times the length,
Let's do this.
yeah, plus 2 times the width. 2 times L plus 2 times W. That's the formula for perimeter of a rectangular, because it says what? A rectangular mat.
Okay.
Right? Okay, so what's the length, Latoya?
X, the radical X plus 2.
What's the length?
4 meters.
4 meters. What's the parameter?
4 meters.
And what's the parameter?
2L and 4.
No,
That's
what's
8
the
again.
value of the parameter in the problem?
4 meters.
No, parameter,
X.
24 meters.
24 meters. Which of the following shows the value of X if the parameter is 24 meters? So for P, we put 24, right?
Mhm.
All right, Latoya, what was the length?
4.
Okay, so that would be 2
Looking for
times 4. What's the width, Latoya?
You got 1 times 4.
Okay, 2 times 4. Thank you, Maureen.
I do it different, Miss Barbara.
Okay,
That's a 2L plus 2L and that. And
and
I
so
did
what?
it under the radical.
Okay, so what's 2W equal to?
4,
No,
it's 8.
the width is the radical x plus 2. So this will be 2 times what?
2 times X.
You got a radical here, Maureen.
Yeah, it's x plus 2 under the radical.
Under the radical, that's right. So this will be 2 times the radical. Now,
Yeah.
this is all under this one radical, even though you see it as, let me just do it like this. This is all under one radical. And I think I drew a line before, okay? And then I put another parameter here. Okay. So 24 is a parameter. Length is 4, so 2 times 4, that's 2L, plus 2 times W be 2 times the radical x plus 2. All right. Now, what does this give you, Latoya?
8.
What?
2 times 4 is 8.
Okay, so you have
24 equals
24
equal 8.
equal 8. And what do you get for this?
Plus
Plus
2 on the radical thing.
you what?
2x. 2x.
Well, that's 2 times.
Yeah, 2x.
Where are you getting 2x?
Because I multiply under the radical.
2 times the
2x.
square root of x.
Yeah.
Okay. So 2 times square root of x plus 2 times 2, right?
Yeah.
Because 2 times this expression is really 2.
Oh.
Well, let me do this because let me do an asterisk because we're using x for an unknown, right? So let me put an asterisk for the time sign. And remember, you can use an asterisk or a dot. So 2 times the radical plus 2 is 2 times the radical plus 2 times 2, right? So what did you write, Latoya?
I put 24 equal to 8 plus 2x.
What did you put?
2x. And the radical.
You put 2x, 2 times the square root of x, you put 2x.
Yeah, and then I put it back under the radical. I put x plus 2. I do it a different way.
Okay,
That's how
tell
I did
me
it.
what you wrote then.
I put it just like all the 24, and then I put equal 8 plus the 2x under the radical again. That's what I do.
So you wrote
And then
2x
I did
and
12
then,
minus, and then I did I did 12 minus 4 equal 8 under the radical 8 plus 2.
okay, so what did you have after this 2?
After that 2, I put it back under the radical. I told you.
Okay,
It
so
was 2. It was 2 parentheses and the 4 plus x plus 2. I do it the long way.
okay, so this 2 square root of 2 plus 2 times 2, you got what?
4.
So this is a 4 where I have a 2?
Yeah, I do it a different way. You're
Okay,
doing it the long
so
way.
just tell
So
me what you
that's
did.
why
You have
I'm kind of
4.
confused.
Okay, so you 4 times what?
The plus the 4 plus the x of the parentheses thing. X plus 2. I have 4 8 plus the 4 under the radical.
So after the
That's all I did.
parentheses, you have a radical?
Yeah, I had the radical. No, I had 4 outside plus the radical. I had 4 outside the the radical
Oh,
plus the
so
radical.
you had 4, and then what
Yeah, I
followed
had
the
4
4?
by, yeah, and then the x plus 2 under the radical. That's how I did it. But I got 62. So I don't
Okay, 4 times the parentheses, and what did you have after the parentheses?
4. I had 8 plus 4 plus the radical. X plus 2 under the radical.
8 plus
That's
4
what I did.
plus 4. And what
Yeah.
followed the 4?
And x plus 2 under the radical.
Okay. No, okay, this.
I jump up my own. I don't know if I'm doing it
Okay,
the way you want it to do.
okay. So you had, okay, let me put what you said.
Because I do it different ways. Because I'm
Okay.
like confused. I don't know.
Is this what you had?
No, I had let me tell you what I had. I had 24 equal 2, 4 plus under the radical x plus 2. Then I said 24 divided by 2 equal 4 plus the x plus 2 under the radical. Then I had the 24 divided by 2 give 12 minus 4 equal the x plus 2 under the radical. Then the 12 minus 4 equal 8. And it's equal x plus 2. And then I put the 8 as an 8 square equal x plus 2 under the x plus 2 squared. And then 8 squared is 64 equal x plus 2. And I said x equals 64 minus 2 give you 62. That's how I did it.
That sounds like a lot of steps.
Just what I tell you, mine is long. I told you up front that mine was long.
Okay,
I do it the best way how I know how to do it.
all right.
That's why.
Yeah, you got the right answer. Okay, so perimeter is 2L plus 2W. Now 2W is 2 times the width that it gave you as square root of x plus 2. So 2 times 4 is 8, right? So this is really 2. Let's just leave that as, let's just copy this and leave it as 2. Let's just recopy this. 2 times 4 is 8. And then let's just repeat what we have here. This expression right here. Let's just. Okay, so 2 times 4 is 8. That's the 2 lengths. So we got 8. And we can subtract 8 from both sides, and that would be 24 minus 8. Okay, so we subtracted 8 from both sides, and that would be equal to this whole expression. This would be 8 plus, and just repeat this whole expression, which is our 2W. And that would be minus 8. Okay, so what do you get on the right side, on the left side? 24 minus 8 is what? 24 minus 8.
16.
16. 24 minus 8 is 16. So this is 16. And then 8 minus 8 is 0. So on the right side, we just get this whole expression again. Okay. Now, remember this 2 is multiplied both the square root of x and by the square root of 2. Okay, because this is all underneath the radical, right? Everybody following?
Yeah.
Okay. So let's just copy that on the other side. Because our problem is what is X? That's what they ask us to find, the value of X. So let's just copy that and put it on the other side. Okay, now, when you multiply a number times something on the radical, it's multiplied by both. If it's two expressions, it's multiplied by both. So that's 2 times square root of X plus 2 times 2, right? Okay, so let's just put 16 equal, and that's 2 times, and I'll use the, okay, and that's times the square root of X. So let's just put, that's all under that radical, the square root, the X and the 2. So that's 2 times square root of X plus 2 times 2. Okay, so this is, I'll put parentheses here, plus 2 times 2. Okay. Now I'm kind of switching here because I used the asterisk for the times here and I use the just the parentheses, but I could have just, well, let me just stay consistent. Okay, 2, I'll put the asterisk back there, times, and then I don't need the parentheses. All right, now, so we'll have 16. 2 times the square root of 2 would just be 2 times the square root of X, right? And we can just put square root of X, because side by side is still multiplication. And 2 times 2 is what? 4.
4.
All right. Everybody with me?
Trying to, yeah.
Okay.
Yes, Mr.
2
Yes.
times what's on the radical? I just broke it up. 2 is times the square root of X, and 2 is also times 2. All right, so 2 times square root of X is 2 times square root of X, and 2 times 2 is 4. All right, now you subtract 4 from both sides.
Mhm.
Subtract 4 from both sides, right? And what will that give you? 16 minus 4
It's 12.
equals, and let's just take all of this and say minus 4. Okay, minus 4 on the right. So now the minus 4, the plus 4 becomes 0, right? 16 minus 4 is 12. Plus 4 and minus 4 is 0. So what we have left is what? Just 2 times the square root of X. Everybody with me?
Mhm.
Okay, now what do we do next?
Latoya, you teaching us.
What do we do next? We want to solve for X.
Okay.
12, we'd have to divide both sides by 2, right?
Huh.
Divide both sides by 2. Both sides by 2. Okay, and if we do that, 12 divided by 2 is, well, let me just write it here. I don't want to short step it here. Okay, let's put that here. Divide both sides by 2. 12 divided by 2. Let's just put it underneath here. And then the right side divided by 2. Right? And what's 12 divided by 2?
6.
Okay. 12 divided by 2. And this divided by 2. Okay. And that would be 6. And that would be equal to square root of x.
Mhm.
Right? Square root of x. Okay, now how do we solve for x if 6 is the square root of x?
You multiply.
Multiply what, Maureen?
I don't know. Must be 6 by the square root of x. I don't know.
No, if you want to get this x, you'd have to square both sides. Because if you square a square root, I think I mentioned that before, you get back the same number, right?
Mhm.
If you square the square root, you get back the same number. So square the 6. Okay, so we say square both sides. So 6 times 6 would be 36. 6 square a square root, because square root is really a number raised to the 1/2. So that would
Mhm.
just give you x. Okay, so x would be 36. Let's see if that works. Okay, the perimeter is 24. So 2 lengths plus 2 widths should be equal to 24. The 2 widths was what? What was it? Okay. The length was 8. So the 2 widths should be equal to what? 16.
16.
And then 16. No, where did we went wrong somewhere. Two times 4 is 8. 8 from 24 is 16. Okay. The square root of 36 is, now what we got? So square root of 36 is no, the square root of 36 plus 2. That's not a perfect square root.
6.
No, it's the square root of x plus 2
Oh,
is the width. Let's see, where did we go wrong here? Okay. 2 times 4 plus 2 times the width. Okay, so 2 times 4 is 8. Square root of x plus 2. All right, that's 2. 24 minus 8, 16. And this is 8 plus 2 times square root of x plus 2, which is 2 times square root of x plus 2 times 2. Let's go back here. 2 times square root of x plus 2 times 2. 2 times square root of x plus 2 times 2, which is 4. Subtract the 16 Subtract the 4 from both sides. 16 minus 4 is 2. Square root of 2x plus 4 minus 4, that's 2 times square root of x. Square both sides. Divide both sides by 2. 12 over 2 is 6. And this is square root of x. Square both sides, we get 36 equal to x. But when I put my 36 plus 2 is 38, but that's a square root. But that's not a perfect square root. (62) plus 264, perfect square root would be 8. 2 times 8 is 16, plus 2 times 4 is 8, and that gives you 24. So I should be getting a 62 answer. So where did we make an error? X should come out to be 62. So when I substituted in this radical, 62 and 2 is 64, square root of 64 is 8. So the width would be 8, and 2 8s is 16, plus 2 4s, and that would give you 24. So where did we make an error? Does anybody see it? 2 L's plus 2 W's. Two times square root of x plus 2, 2 times square root of x plus 2 times 2. See, everything is under this radical, even though I don't have the line all the way across. Let's see. Okay, I think I'm going to just leave it. I have the solution on another page, but I don't have it. So this one, I'll send you the solution when I send the session, because it should come out 62, because then when you put the 62 underneath the radical, you get 64, and the square root of 64 is 8. And 2 8s is 16, plus 2 4s will give you the 24. All right. So I'm not going to spend any more time on but I know there's an error someplace. It's kind of just, I don't see it. Okay. The correct answer is 62, and I'll send you the solution, because I really don't see it on here. It's kind of hard to see it sometime on the screen. All right. So I will send you step-by-step solution to number 2. And now I'll go to number 3.
Okay.
And number 3 is all perfect squares, right?
Mm.
What's the answer, Maureen?
All right, bet.
What's the answer?
Let me see.
Square root of 25 is what?
5, 9.
What's the square root of 25?
Bet. 5.
And what's the square root of 16?
4.
And what's 5 times 4?
20,
What's the square root of 36?
6,
And what's 20 plus 6?
26.
So what's the answer?
B.
What's the
B.
B? Does everyone follow
Yes,
number
I
3?
got that right.
Yes, very good, because you've got to do the multiplication. Remember PEMDAS.
Mhm.
Mercedes, you had a question?
Yes, I don't get it clear. Oh, she. That, let me ask this question. You mean she's getting numbers that can go into the three of them, 3 squares number? I don't get something clear right there.
Okay. Maureen, you want to explain it?
You said the square root of 25 is 5, right?
Right.
Yeah, yeah,
And the square root of 16 is 4.
yeah.
There we go.
4, 4 to
So
16.
you then you multiply 5 by 4, right?
That-
And you get
that's-
20.
Yeah,
And then you say the square root of 36 is 6. And
Mhm.
add the 6 to the 20 and get 26.
So that's 20 plus 6 equals 26.
so you're saying that 4, no, sorry, 5, 4 plus 6 is
No, 5
the,
times 4.
5
No, no,
multiplied by
no,
4.
5 times
no,
4 plus 6.
More Mercedes, square root of 25 is a 5.
no, let
Maureen
me
said.
ask, let me
Go ahead.
try to explain what
Mercedes.
I'm saying. I'm saying, so you're saying that using 5 and 4 to get 26 is a perfect square root for the 3 numbers?
No, no. This says square root of 25 times square root of
Or-
16 plus square root of 36. Just do the mathematical operations.
Or maybe I don't understand your question. Which of the following shows simplified expression for?
Simplify means to cancel.
So what you want to do is to get 3 numbers that simplified 25, 16, and 36.
No,
And
no,
when you
no,
add-
no,
and
no,
when you
no,
add
Each
no,
one
them-
has
no,
to- 1/4.
Mercedes, hold on.
Yeah.
You're making it more difficult than what it is. All it's saying is
Yeah,
take the square root of 25,
yes.
take the square root of 16 and multiply them. Add that result to the square root of 36. So what Maureen said is square root of 25 is a 5. Square root of 16 is a 4. And she multiplied them because it says multiply, right? That's the times. And a 5 times 4 is a 20. Get the square root of 36, that's a 6.
Mhm.
And a 20 plus a 6 is 26.
I understand that. No, I thought it was like, oh, I'll get to you with the question and say no.
Okay,
Thank you.
because I'm just saying you're making it more difficult than what it is. It's saying,
In my head, I'm thinking about square root. And I'm saying square root. That's 26.
well, they are square roots,
Yeah,
but
yeah.
it's just
But
like if you didn't have the square roots and you just say 25 times 16 plus 36, what would you do first? The multiplication, then you do the addition. Except here, you've got to take the square root and multiply.
So why does 25 carry a X?
No, this is a times. That's a times.
Oh, times.
Okay.
It's look like they're not, we're using the
Okay,
coefficient.
let me remember, multiplication can be asterisk, dot, parentheses, X. All right, all those
It's there,
represent
it's there.
multiplication or side by side.
Yeah, I know the signs.
Yeah,
it's
so
there.
25 with the X is times. I
You see,
just
we
made
put
it
that-
asterisk.
It was so near to the 25. I thought it was just X. But I got you. I understood
Got me?
now.
So square root of 25 times square root of 16 plus square root of 36. Multiply the 2 square roots, then add the square root of 36. Got it, Mercedes?
Yes, thank you very much.
Okay. All right, so that was number 3. Latoya, what happened on number 4? Latoya, where are you? Latoya, you're on mute.
Is she sleeping?
No, she may be. Latoya, what happened on
Yeah,
number
I didn't do
4?
it.
You did it, but you did it incorrect. I was
Oh,
surprised. That,
uh,
what did you think this X right here was, Latoya? What did you think that X
I
right?
didn't know.
That's an exponent.
Year.
Did you do it, Audrey?
I write down, but I don't know if I read it right.
Okay, tell me what you wrote down. I'll write
I put-
down.
Okay, I put TX equals 12 times 1.12 to the X in parentheses plus 2011 minus 2005.
No. X
That's how we do
is
it,
the
right?
number of years after the expansion in 2005.
Oh, after.
So from 2005 to 2011, Audrey, is how many years?
6 years.
6 years, right?
Mhm.
So that means that exponent is going to be a 6, right? So all you had to
Mhm.
do was put a 6 here.
I thought it said just written.
I say show the setup only.
Oh, sorry, sir, only.
oh, Miss Barbara, so that's what I did, but I put the X down lower.
I
That's why
know
got
you,
it wrong.
I know you did, but you put it like it was a times, but it's not a multiplication, it's an exponent.
Well, I do, I can't have the time too. That's- that's how you
1.12
do it at the
is
time.
raised to the X power. That's why I asked
I
you,
do it
what
at
did
the
you
time
think
too.
the X was?
Because it was like, why she said wrong? I was confused.
Yeah,
Because I know it was right. You said-
yeah,
you
but the
said set up
X is a,
only.
the X is an
You didn't say she was
exponent.
working. Oh,
Yeah, the X is an
Oh,
exponent.
God.
It's only the difference between the
that's
years,
a
what?
mess. I'm hurt.
You driving, Latoya?
Hmm?
You driving?
Yeah, remote.
Okay.
No.
No, I had to
See,
do it.
X is
Why-
the
why did I
number
go to the
of
top?
years after the expansion in 2005. So how much money is being spent in 2011 is 2011 minus 2005. So this X becomes a
6, right?
6.
That's what I said. I had that. Right? I
That
said
was it.
2006.
That's all you had to put.
Yeah, but
Oh,
I
I
put
didn't do
the
that.
X
I told
low
you to find it.
down.
I did that.
Yep.
I just set it up. You know how
So-
I think I just set it up like that.
So Audrey, you had some extra things in yours. All you had to do
Yeah.
was take this expression and put the 6. 2011 minus 2005
But
is
that
6.
way, I see, I take the 2006 and subtract that 2005. So I thought that's what he wanted to be.
I think you said
No, but what did it say?
set
It
up
said
only.
X is the number of years after the expansion in 2005. So after 2011, and the difference in 2011, 2005 is 6. So that
Mhm.
exponent X represents the number of
Right.
years.
Instead of written that 211 minus 205, I should just write 6.
That's it. Because it
Yes.
says X is the number of years after the expansion. So the number of years after the expansion is 2011 minus 2005. So this was your answer. That's all you had to put. Just take that
Okay.
expression and put the
Mhm.
number of years. So all you had to do was subtract the
Okay.
2005 from the 2011. Got it?
So
Barbara
Miss,
always have a tricky math.
I'm telling
You
you.
think that was tricky?
Yeah, because I had the 6, I had it right. I just put it in the wrong place.
You gotta think. It's very
Latoya,
good.
Latoya, what you said is contradictory. I had it right, but in the wrong place. Something's wrong with that statement. I had it right, but in the wrong place. I love that, Latoya.
Oh,
Well,
man.
I
It's
know
not
what,
right now,
I
then.
know exactly what you mean.
Oh boy, I was so confident that I won. That's what I'm confident about. I
But
was heartbroken when I got it wrong.
Does that X look like a multiplication right here?
That's always Earth. You put your mind until you
That
get it. and
X
you
there,
say,
what does
"Oh,
that look like to everybody? Doesn't that look like an exponent?
yeah."
Yeah,
TX.
but it looked like an asterisk,
Yeah.
but I was like,
No, it's raised to the X power.
X
Oh,
power.
it's like me the
maybe
next
if I did send
You
it
see
in
up
the
in the-
email, maybe if I did send it through the message and I see it was an exponent.
And I said set
Oh,
up
God.
only, so you didn't have to calculate anything. You
Yeah.
just
I
had to.
know, because I told you I was very
Up in the-
confident about that one. I was getting it right.
But you had the X as a multiplication, and it's a power. X is a power. And you were given 2 years, you take the difference, and that's what the power is.
That's
Six.
the only little
I
part I
thought,
get
I thought it
wrong.
was 12. I thought the 12 was somebody deployed, but that 1.12
So, Miss,
and then add that 6. I thought that was.
Miss,
But you got the 6, Audrey. You were just supposed to use it as an exponent.
Yeah, but I didn't know what to do with the 6 then.
What did it say X was? Read that, Audrey.
Year. It says X was
Number
the
of years
of
after
years,
the
yeah.
expansion in 2005.
Yeah.
so Miss,
So
why
I
go
want
back
to say
to how
after
much
12. So
money
that means I take 12, I take
is
4
to be
from
spent?
11, you get 6, but then I didn't know how to write that there.
So, Miss,
Yes,
the
Mercedes.
the last question is a trick. Well, for us to think, Miss, like how much money is being spent in 2011?
But if you read this, Mercedes, the total T of X in millions of dollars can be
Mhm.
estimated by the expression
Yeah.
T of X equal 12 times 1.12 raised to the X power, where X is the number of years after the expansion in 2005. But it says T of X is millions of dollars. That's money spent.
Mhm.
It says
What
it
is asking
continues
them-
to increase, right?
Yeah.
So how much money is being spent in 2011? The number of years since the expansion is 2005 subtracted from 2011.
That's the money that's the money 6.
That's money spent.
Oh,
Because it said, doesn't it say T of X in millions of dollars? Right here.
oh yeah, yes.
Right here. Right? That's money. Is it millions of dollars money?
So the X stand in place of the number.
X is the number of years right here,
Right.
not money. T of X is
That's what I'm saying.
Time,
If you're not
time.
thinking,
T of X is the money. X is the number of years after the
Yeah.
expansion.
you see, this math is new to me, and if you was doing it like this, then I would be looking at it and looking for how much money to be spent in 2011. That's the answer I was looking for. I'm just
But
saying that.
the money spent is represented by this expression T of X.
Yeah.
So you calculate the money spent by multiplying 12 times the factor 1.12 raised to the X power, where X is number of years.
Okay.
So if you raise this to the power, multiply by 12, what you get is the money. Got it?
Got it, miss. But to me, the last sentence was necessary.
What do you mean the last sentence?
How much money is to be spent? Because that's not the answer you're looking for. How much money? You're looking for how much years?
But when it says show the setup only, the money is represented by this expression, Mercedes,
Oh.
right there.
Oh, yeah.
That expression represents money, right? So all you had to do is just repeat that expression and find the number of years that has elapsed.
Okay.
You got it?
Yes.
All I wanted was setup. You didn't do any calculation. You just took that expression they gave you and substitute what X is. X is the difference in the 2011 and the 2005. Questions on number 4. That's why it's so important to read these word problems.
And look out for the details. Oh, boy.
Yes. But ask yourself, what is the money? The money is the T of X. What is the X? The X is number of years. Okay,
Okay.
that's the variable. The variable here is the power X. All right. We normally don't think of variables as being exponents, but they can be exponents, right?
Yes.
Okay, Maureen. Oh no, Audrey. Audrey, number 5.
Yes.
I want you to do, did you do number 5?
Number 5 was number 5 now.
Evaluate this expression.
Four. I don't know, I put
That one was tricky, Miss Barbara.
4, 8.
Yeah, you had it right though, right? Audrey, what's
Yeah, I
the
had
answer?
it right.
Yeah, you had it right. What's the
4A
answer?
plus 3.
4,
4A plus 3.
Audrey,
Oh,
what's the answer?
I don't know. I actually wrote it back. See, I put 4x plus 250 plus 25.
You put what?
That is 2B, Audrey.
Huh?
It's 250 and 2B0.
Oh, it's a B?
Yeah.
Yeah.
Oh, I thought it was a 0.
What was your this is to the 0 power.
Oh, yeah.
0 power, 0 power. So what did you
Oh.
have, Audrey?
I had 4A.
You had 4A.
X. I said 4x plus 250.
You said 4AX.
I know that's the X.
What's X to the 0 power?
It's 0.
Any number
Zero.
to the 0 power is what?
1.
0.
1. Audrey.
One.
Oh, yes, the 4 is
Any
1.
number of variables to the 0 power is
yeah.
1. So that's a 1, right?
Yeah, that should be 1, yeah.
So what did you have for the 250 to the 0 power?
I put the same thing, 250. Zero to the 0 is 0. 0 to 5 is 1. And 0 to the 5. 0 to the 2 is 1. And then
Wait
0
a
to the
wait a
5
minute. Maureen, what's 250 to the 0 power?
250 to 1.
250 to the 0 power is equal to what?
251. 250 to the power 1.
250 to the 0 power.
Is 1.
It's
I
just
thought it's 1 to the
1.
5 and 1 on the 2.
1.
So I thought the
Any
1
number to the
one.
0 power is 1. Any
yeah.
variable to the 0 power is 1.
You're right.
So
So that means
250
that
to
so
the
the 5
0
only 1?
power is 1.
1. Plus.
Audrey,
Uh-huh.
in any constant, that is any number to the 0 power is 1. That's the 0 power of the exponent rule. So if it was 1,000 to the 0 power, it would be 1. So that's 1. Audrey, you got it?
Any power to the 0 power is 1.
No, not any power. Any
Any number.
number or any variable to the
Oh,
0 power
variable.
is
Oh.
equal to 1. That's why you said X to the 0 power was 1, right?
Okay.
250 to the 0 power is 1. What about the next one, Audrey?
Oh, it could be
2b
said
to the
250.
0 power. What would that be?
2B?
2b to the 0 power.
You got everything here wrong, boy. I tell you. I take that. I got 24. Where do we get that 24 from?
It'd be
You make that
2b
like a 5.
to the 1 power.
2B to the 1 power or to the 0 power?
What is 2b to the 0 power equal to, Audrey?
Is 1.
What are you gonna do with the 2? It will be
Hmm.
2
B,
times 1. So it'll be a 2.
Hmm.
2
Let me see what you got
times
here.
1.
4, yeah.
What is that equal to, Audrey?
2 times 1.
Audrey, what's 4a times
Okay.
1 plus
4,
1 plus 2? What is that equal to?
7. Yeah.
How are you getting 7? What's 4a times 1?
It's 4. Yeah.
Just 4a, that's right. 4a. And 1 plus 2,
It's 3.
3.
Times 1 is 3.
That's it. Because 1 and 2 times 1 is 2, and 2 and 1 is 3. So 4a x to the 0 power is 1. 4a times 1. 2/5 to the 0 is 1. 2b to the 0 is 2 times 1, because b to the 0 is 1. So add the constants, 1 and 2, and you get 3. And then 4a times 1 is 1. So your answer is 4a plus 3. Questions, anybody? Audrey,
Just trying to catch
yes.
up on.
Mercedes?
I'm just saying I was here to catch up on this, Miss. Just looking at it, I'm not so familiar with this term. I didn't get to study so much of the poem, whatever you call it.
Because I sent you exponent rules. This is the 0 power of the exponent
Yeah.
rule. Any number variable
So-
to the 0 power is
So,
1.
so Miss Barb,
Yes,
Miss Barbara.
yes.
So if you have 0 to the 1, 2, 3, 4, 5, 6, 7, 8, or 9 power, it is 1.
No, 0 is never really raised to a power. All right.
No. What about the 1? 1 to the 0 power.
1 to the 0 power would be 1. Any number to the 0 power is 1. A million
Okay.
to the 0 power is 1. 1,000 to the
Okay.
0 power is 1. 25 to the 0 power is 1.
Mm.
Y to the
I
0
know
power
we get
is
25
1.
from the, that, you know, that be as a 5. I know my brains look at bad.
Which one?
I know we get a 5 from the,
Give me plus 2b0.
yeah, that would be, I know we get that 5 from that be as a 5.
Oh, you took the
I know
B
we get
here
that
as
from.
a 5?
Yeah, I try to be as a 5. I know how you get that.
Well, 25 to the 0 power would just be 1.
Yes, but I don't know how we get a 5. It should be a B. That's what I'm
Yeah,
saying.
it's 2b to the 0. So b to the
Yeah.
0 is
I copy it
1,
wrong. Yeah,
and 2
whatever I
times
did
1
it wrong.
is 2. 2, 5
Mm.
to the 0 power is 1.
Mhm.
4ax to the 0 is 4x times 1, because x to the 0 power is 1.
Mm.
Is it clearer now, Mercedes?
Yeah, I
Not
think
quite
so.
sure yet. Still
So
thinking.
Miss Barbara, you get 4a, right? Equal to
Yeah.
4a. How you get the 3?
What's
4f?
2/5 to the 0 is 1.
Uh-huh.
2b to the 0 is 2 times 1, because b to the
Uh-huh.
0 is 1. 2 times 1 is what, Maureen?
2,
And 2 plus 1 is what?
3.
Ooh.
That's
Oh,
how we
3.
got the 3. You got it?
Okay, yeah.
And that's how we got the 3.
Okay. But I remember that any number to the 0
Any
is
number
1.
of variable, Audrey.
Or variable.
And variables are anything from A to Z.
Okay.
Got it?
Yep.
Yes,
Okay,
I think I got it
So-
now.
all right.
Yeah.
all right, so let's
That's
go to
cool.
number 6. Add polynomials.
5,
Okay, Audrey, how would you add
6.
these? You can add like terms, right?
All the late terms, you add all the late terms.
Yeah, so what did you get?
Now we get it. This way get all the late terms.
You've got Q,
Okay.
you got Q4
Q
here,
to the
Q to the
4th.
4th, and Q to the 4th here. You got R to the
Plus
5th and
8Q.
R to the 5th. So what,
I say 6Q to the 4th plus 8Q to the 4th
and that gives you what?
plus 10RS to the S, that's S, right? To the 5, sorry, to the 5th.
Right?
Minus 12R to the 5th.
So what was your answer?
My answer was 0. Q to the 4th and R to the 5th. I'm not fit right.
You got
That's how
what?
you write it.
You got
I
what?
got 0.
How do you get 0?
Let me tell you something. I get 2Q. Let me tell what I did here.
Okay,
Oh,
now
dear.
your like terms are, okay, let's just take them separately.
Negative 6Q to the 4th. I know we do that, do things like that.
Okay, so you have
And the lamp
negatives.
pose. Negative 6Q to the 4th.
Okay, and then you added to that 8Q to the 4th, right?
Yes. And you get
And then you
18Q.
have 8Q to the 4th. You get what?
Well, I mean, you got to add 6Q4 to 8Q4.
What is
Yes.
that equal to, Audrey?
14
What?
Q to the 8.
No. Unlike signs, you subtract.
Yeah, that way get messed up. That's where you get messed up.
So what's your answer? Subtract the 6 from the 8, and the number with the biggest number sign is what you would use. Or you got more positive and negative, you use negative. You got more negative than positive, you use negative. So what would be the answer, Audrey?
14.
No, you got to subtract.
Q, 2Q to the 8.
Oh, I
Mhm.
subtract. Oh gosh.
What do you get, Audrey?
I subtract the 8. Oh my
The 6
God.
from the 8 is what, Audrey?
2. I
Audrey,
subtract the 8 from the 6. So 6 from the 8. I subtract the 8 from the 6. Negative 6.
6
Minus
from the 8
That's what you do.
is what, Audrey? What's 6 from 8?
Oh yeah. It's 2.
2. Okay, now, do you have more positive or more negative?
More positive.
More positive. So your answer would be what?
2Q.
2Q to the
Let's see what we do
4th.
here. Yeah. 2Q
Be a plus. Because you have
plus 0.
plus 8 minus 6. So the 8 is the biggest
2Q.
number. You have more positive than negative. So your answer will be plus. So the default is plus. You don't have to put it there, right?
2 to the 4.
Okay. So that's those terms. Now let's go to our R terms. All right.
Okay. 2
Now we
2 to
have
the
what?
4th. I got that there. Plus
8. We have 10R to the
10R.
5th. We have 10R to the 5th.
QR
10R to the 5th.
Mm.
There we go.
2Q to the
And we have a minus
plus 2R
12R to the 5th, right?
plus
Minus
2R
12R to the 5th. Those
Okay.
are like terms, right?
2R
Same
minus 2.
base,
from 12
same
to 10.
exponents. So
Let me
let's
see.
just do this. So Audrey, what does that give you?
Huh?
10R to the 5th minus 12R to the 5th. What is that equal to?
Let me see. Let me check my calculator. Oh man, 10R
10R to the 5th
minus 12.
minus 12R to the 5th. What is that equal to?
Is 2 To the 10th? I
Why are
don't
you
know what I
getting
did here.
10? You don't change the exponents
It's
when
5.
you're adding or
Oh, yes,
subtracting, your
yes, 5.
exponents stay the same. So you
Ah,
subtract and you got a 2, is it minus or plus?
yes.
Audrey, is it minus or plus?
Huh?
The 2, is it plus or minus?
The 2 is a minus.
That's right, very good. So minus, and this would
I
be
got, I got 2
R.
to the 4th. I got 2q to the 4th
r to
plus
the 5th.
negative 2r to the 5th
Right.
equals 2 minus 2. I don't know how you get that.
What did you get,
QR
Audrey? So that's your
4
answer.
to the
2q to the
huh?
4th minus 2r to the 5th. So this would
minus
be,
2r to the 5th.
okay,
That's the
that
answer?
that's
Yeah.
the answer. 2q
Well,
to
you
the
got that
4th
there. What?
minus
Yeah.
2r to the 5th.
2r to the 5th. Oh no, he got it wrong. I have plus. I got plus negative 2r to the 5th. That's what I got.
No, but your 12
Okay.
is bigger and it has negative, right? So
That's
your
okay.
answer is going to be negative.
Negative, yeah. So I got
So that would be your
2q
answer.
to the 4th.
2q to the 4th minus 2r to the 5th. Or you could have put your minus first and said minus 2r to the 5th plus 2q to the 4th.
I
Same
know I got
answer.
these minus 2r at the last.
You had minus 2r to the 5th?
Yeah.
Okay. Did you have 2q to the 4th?
Yes.
Okay. So that's your answer. 2q to the 4th minus 2r to the 5th.
Mm. But I thought I had to calculate that. I thought I had to like
No,
add
this
up
is meant to
all of that.
math. This is meant to math. Because you only doing operations on the coefficients. So if this is a minus 6, a plus 8, a minus 6, and a plus 8 gives you the plus 2. And you can only do this when you have the same base and power. See, q to the 4th, q to the 4th, right? And then
Yes.
r to the 5th, r to the 5th. 10r to the 5th minus 12r to the 5th. Subtract, you get a minus 2r to the 5th. Got it?
No, I had a minus. I had add. I had add.
No,
I
but
had that.
no, you have to have the
Yeah.
minus because look,
Yes, I understand
you
what you
got a
say. Yes, the
12.
bigger
Yeah,
number.
yeah, the bigger number.
The bigger number.
The bigger
yeah.
number lets
Yeah.
you know what the sign is. Or just logically thinking, you've got more negative than positive, so your result will be negative. Here, you've got more
Okay.
positive than negative, so your result is going to be positive. Okay.
Okay.
Question number 6. Now, let's find the greatest common factor of these monomials. We did some of these before. You remember how we did them? Mercedes, you remember how we did these?
Please, I'm thinking, I'm not sure. That's, what number is this one?
What is the greatest common factor,
Common factor.
of these monomials? So we really at number, this is number 7.
6, 7.
I think it's 6 because 7 is below that.
Let's see, 6. And
It is 6 different things that you have here. 7.
yeah, but
something like that.
this is 7, actually. This is 7. And on the 7,
but
we
seven
have
is not wrong.
these. Okay. And then factor these polynomials. So it comes after 6. So 7 is like several terms here that you define the greatest common factor of. And remember, the greatest common factor includes both the coefficient and the variable. All right. So what's the greatest common factor of 18 and 48?
Would that be 9?
9 times what gives you 48, Mercedes? Does 9 multiply a number to give you 48?
Just a second. No, miss. I'm
Nope.
wrong.
Can't be, right? It's got to be a number that you multiply by and
Okay,
get
can I try
both.
8?
You said 8?
Yes, miss.
8 times what gives 18?
6. Oh, sorry. I thought you wanted to say 48. Give 48. That's why I say 6. Okay. What times? 2
What-
times 8 give. Oh, no.
What are some numbers that
No,
are
9 is 9
factors
miss.
of 18 and 48?
Okay, miss. 9. 9 is 1.
9 times what gives you 48?
9 times 2. You got a 4. I thought you were going to say 18, miss.
But it's got to satisfy both Mercedes, both
All
the
right, okay.
18 and the 48.
Oh, Lord. Okay, I got you.
What number divides into 18 and also divides into 48?
Can it be 6, miss?
Yes, 6. So that would be your factor for your numbers. What would be the factor for the variable t?
Variable T. That's one can't remember.
Now you have a t and a
five,
t to the 4th. No. What would it be?
T5. T5.
No. Remember,
No.
when you give me a number, when you give me the
96.
variable, it has
Yeah.
to be a variable that goes both into the t and into the t to the 4th. So it can't be a t to the 5 because t to the 5 does not.
Two.
I'm
Three.
talking variables now. You gave me 6 as the factor for 18 and 48. Now give me the factor for t and t to the 4th. What is that factor?
T to the 2. Or maybe I'm misunderstanding.
No, it has
Except
to
for
be.
48.
No, it's always the lowest
One.
variable. It's always the variable with the lowest power. So
One.
what is that?
Then 0 then.
No, we're talking t's now.
I don't comprehend.
3.
I don't comprehend the T.
T to the what power can be multiplied to give me t and also
3.
give me t to the 4th.
Can be 1 or 2.
Third.
I'm talking t now. You got to tell
T
me
to
the
the
t.
3rd.
No,
T-
t to the 3rd is too big, Audrey.
T to the 1 or T to the 2.
What she said? 2.
It's
2?
t to the
T to-
1, Mercedes. You said it, t to the 1. So it would be 6.
Times T.
Yes, that's right. Be just 6t. That's your greatest common factor. In other words, let me just put this here. If you put the 6t and you multiply it by 3,
Let me see what we put here.
that gives you 18t, right? 1,
Mhm.
8t. And you take that same t and multiply it by what?
Which, yeah,
8
or 6
t to the 3rd,
times 3. Okay, 6 times 3.
8t to the
6 times
3rd. So
3 to the
let's put a
3.
3 here.
And 6.
All right.
See what she's doing now. 6 times 3
Okay.
to the what?
So it's always your variable with the lowest power, and that's your t. You follow?
6 T to the
Because
3.
whatever you pick as your greatest common factor, when you multiply it by some number, you should get back what you have here for your monomial. 6t times 3 is 18t. 6t times 8t to the 3rd, that's equal to 48t to the 4th. That's equal to this 48t to the 4th, right here.
So the 48 one more again, miss. You said whatever you get.
okay, so you understand how to get the factor for the numbers, right? 1848, because we've done those before.
Yes,
But
yes,
when you're getting for the variable, always use the variable with the lowest power, and that's the
Yes.
t.
yes,
Because now if we take the t, we can multiply it by a number and get 18t. We can take that same t and multiply it by an expression and get back our 48t to the fourth. It's always your lowest. That is
Number.
your variable with your lowest power. You got it?
Yes, miss.
See, it can't be like you were telling me t to the fourth, but see, you can't have a t to the fourth here. How are you going to get your 18t? You can only get it with a t, right?
Okay.
You got it?
Yes, miss. What?
So always use the powers that are the lowest.
So the letter,
So why do you put
Always,
three,
go ahead.
why do you put 3 in the bracket?
Because
It multiply 3 by 6.
I want to get back these monomials.
Oh, 3 6 is 18.
So when I get a greatest common factor, I want to multiply it by some number
Get
and
back
get
that
back
number.
my monomials.
Okay.
So a 6t times a 3 gives me 18t. A 6t times 8t to the third, 6 times 8 is 48. T times t to the third, remember you add the exponents, 3 plus 1 is 4, t to the fourth.
Oh,
Is it making sense now? Is it making
Yes,
sense,
yes.
Mercedes?
yes. A
So,
lot.
so
What?
then you're ready to do number 2, right?
What?
Yes, you're ready to do number 2. You volunteered,
Sure.
right?
Ah,
I volunteered you. Okay, let's do the 18 and the 26. What's the greatest common factor of those two numbers?
Greatest common
The 18 and the 26.
The 18. Let me see what going to.
What number goes in the 18 and goes in the 26?
6, miss.
6 doesn't go into 26.
Oh, Lordy. Okay.
13 twos, 2.
What do you think it is?
2,
Audrey, did I hear you say it? What is it, Audrey?
13. 13 2.
13 doesn't go into 18. I think I heard you say it. Audrey, what is it?
2, miss.
2.
3.
It's 2, right?
Yes, miss.
It's
So I get
2.
2 13 is 26.
Because
So
2 times 9 is 18. 2 times 13 is 26. They both prime numbers, so greatest common factor is 2. Now, look at the r to the third and the t, right? Now,
Yes.
your lowest power is on the t right here.
Yes.
Your lowest power on the r is right here, r to the
Yes.
second, right?
Yes.
So what would be my r and my t, Mercedes? What would be the powers? Which one would I use? Remember I said I always use the lowest, right? So for my r's, would I use the r to the third or the r to the second?
The R to the second.
Right, very good. I used the r to the second, so let's just put our second there. Okay, now we also see what? We see the t to the 1 here and the t to the 4. So which t would I use, Mercedes?
one.
The t to the 1. So that would be t, right? So there would be my greatest common factor. 2
Oh.
r to the second t. Now let's prove it. Right? Let's prove
Okay.
it. Let's take this 2 r to the second t. Put it here. Okay.
6.
And I want to get back my 18 r to the third t. So what goes here, Mercedes? 2 times what gives me 18?
4.
28. What did you say? Give you
2
what?
times what number gives me 18?
2 nines.
2 nines, so that would be a 9. And r to the second, and if I want to get r to the third, this r has to be r to the what?
R to 2.
No, remember I want to get r to the third. So r to the second must be multiplied by r to the what?
3.
No, add exponents to get the power.
4, 6.
So that would just be an r.
Okay.
2 plus 1 is 3, right?
Yes.
And I took the t out, so I don't have a t left, right?
Okay.
Okay, so 2r to the second t times 9r, that would be 18 r to the third. Let's just put r to the third and t, right? And that's what we started with, is our binomial.
Oh.
You got it? 18 r
So,
to the third t.
okay, so,
Wait a minute, Miss
2R to the
Barbara, can you make
second
it a little
power
brighter for me?
Okay,
T
you want to,
bracket.
okay,
Just make it a little brighter for me.
okay, let's make this.
Thank you.
Okay, now, so I have,
It's
The
from
first- saying-
to the third.
go ahead, Mercedes.
You got, so 2R to the second power
to the
with
second.
T bracket 9R.
That takes care of my first
That
binomial,
is equivalent
18
to 8
r to
in
the third t.
third T.
Okay, now let's do the next one, Mercedes. I'll put this here and you tell me what I multiply this by to get my 26 q r to the second t to the fourth. So this would be, now, tell me what goes in parentheses. Now I want to get 26. Let me just put here equal, and then you tell me what goes in the parentheses. I want to get this back, this monomial right here.
R to the 2,
Okay,
T.
so I want to get that. So what goes in parentheses, Mercedes?
26.
What do I multiply to get my 26 when I multiply by my greatest common factor?
T to the 4.
You multiply 2 by 13.
Very good. 2 times 13, that gives me my 26. All right. Okay. But I have a Q, right? So I got to put the Q in because I don't have a Q as part of my factor. So I put the Q, right? Now, what about R to the second?
You put in, yeah. Put in R to the second.
R to the second is already there, right? Because I have it right here. So I don't have to put R. Now, what about my T? T times T to the what gives me T to the fourth?
T times
T to the what power?
T times to the fourth power.
I want to get T to the fourth power. So T times T to what power gives me T to the fourth? What would be the power on T? So when I multiply it by T to the one, I get T to the fourth.
1.
No.
T times 4.
What is it, Maureen?
2.
2 plus 1 is 3. I want T to the fourth.
Oh,
What is it,
That's what I'm-
Maureen? What number adds to 1 to give 4?
3.
3. So this should be a 3, right?
One is 3, yes. The 2 R.
That would be a 3. Okay. And then we close the paren. So when you multiply 2r to the second t, which we found to be our greatest common factor, 2 times 13 is 26.
6.
All right. You have the q, that would give you the q. 2r to the
Yeah.
second t times q would give you the q here, right? And then
Yeah.
then t times
To the-
t to the
the
third
three, yeah,
will
give
give
about the four.
me t to the fourth. But I don't
Oh,
have to put the r because the r is already here to the second, and that's what 26 has, q r to the second. So I don't repeat the r because I don't need to multiply it by anything, r, right?
okay,
So
yes,
this will be 13q t to the third, and when you multiply that out, you get 26q r to the second t to the fourth. Is it making
Good.
sense now?
yes, that makes sense, miss.
Okay.
But
Audrey, you
this,
following?
this exercise, I have to really do some more to get it in.
Oh yeah, we
'Cause
have
it
some
is-
more to do here.
It's really new to me.
Okay.
Start to pick it out
All right.
and get it.
Audrey, is it clear?
Sort of.
Okay. So remember, it's a two-step process. You factor the coefficients. Those are the numbers, 18 and 26. That greatest common factor was a 2. Now you factor the variables. All right. And remember, I say always use the variables with the lowest power.
Okay,
So for the r, the lowest power is to the second power. All right. For the
Yeah.
t, the lowest power is t to the
Is
first power, right here.
yes,
So now you've got, and you don't have a q in both of these, so you don't put a q in the variable. I mean, in the GCF. So it's 2r to the second t. That's your greatest common factor. Now you can, now notice I'm just doing an extra step here because this is extra. Once you get the greatest common factor, you don't have to do this. I'm just showing you how you can check to see that that works.
yes, that is
The
right. Okay.
greatest common factor times 9r gives me back this first binomial. The greatest common factor times 13q t to the third gives me my second monomial, the 26q r to the second t to the fourth. Got it?
Okay, yes. Mhm.
Okay. Maureen, what's the greatest common factor for this one? What's the GCF?
The 12
First-
and 20.
Well, let's first, and I'll make this bigger for Audrey. Okay. Okay. Yes. So let's do it for the 12 and the 20. So what's the factors for the 12 and the 20?
Okay. 4,
You said 4. 4 goes in
Yeah,
the
4.
12 and 4 goes
2 and
in
4.
the 20.
Right.
Okay, so let me just put this on the next line because I can't see it because it's covered by the. Okay. So you said 4. All right. 4 in the 12, 3, 4 in the 25. Both of those are prime, so we are fine. Now, Maureen, what has the lowest powers? What variables have the lowest powers? Maureen?
I listening.
What variables A, B, C have the lowest powers, the lowest exponents?
They all
We
have the
have
same.
lowest. All got the same.
Of these two binomials, they don't all have the same. These are raised to the second. These are raised to the first. Which one has the lowest, Maureen?
For the 20 ABC
Well, not 20, just the ABC,
or the ABC.
right? So
Okay.
ABC, that's your greatest common factor.
So that's the answer, miss?
That's the answer.
Because I was looking to say it was C. Why? It's because C come third. in the
What?
alphabet.
No,
Because C
it's
comes first.
A is to the 1, B is to the 1, C is the 1. These are all
So
lower
that's
than the 2s,
one.
right?
So all of those represent one because they all carry the same number, right? So you just
No, the
bring them
one,
to
the one
Mhm.
power is a default. If you don't see a power, it's a 1. That's default. And we normally don't put the 1 power. That's the
I don't
default. If the power is missing, it's raised to the 1 power.
I still don't get that like a part of it.
What?
You got
What?
3 2.
Go ahead, Mercedes.
You got A to the second, B to the second, C to the second. That's the
You know,
reason
only
why you
the-
eliminate the 2s and just put 4A, B, C?
No, I'm not eliminating anything. Remember, these are monomials. 1 is 12A to the second, B to the second, C to the second. My second monomial is 20ABC. Now, I want to know the grand common factor for these 2 monomials. And 4 is
Oh.
the number. ABC are the variables. So your greatest common factor of monomials are a coefficient and the variables.
Oh, so you have to set a matchup like the 20.
Well, these are 2 monomials. See, what is the greatest common factor of these monomials? These are monomials.
Yes.
One term, one term, one term, one
Yes.
term. All right. Here,
So you got to have
one
this
term,
constant.
one term.
Okay. Oh, I see now.
You follow now, Mercedes?
Yes.
And the 4 is the number that's the greatest common factor, because that's the factor of 12 and 20, because 4 times 5 and 4 times 3, both 3 and 5 are prime numbers. So you know that 4 is correct. All right. Now we go to the variables. We have ABC, A to the second, B to the second, C to the second. And I said, always use the variables with the smallest powers. A to the 1, B to the 1, C to the 1. So now your greatest common factor is 4ABC. And if you multiply this by 3ABC, you get 12A to the second, B to the second, C to the second. For ABC, you only multiply by 5, and you get 20ABC. Got it?
No,
Question?
just me. You fly through that other part. I didn't even get it so good, but I'm
Oh,
starting to get
no.
a part of
The
it.
answer is for ABC. But if you want to check it now, that step I was doing before,
Oh.
for ABC.
So
You
my
wanna
question
check
was,
it, go ahead, Mercedes.
you bring you're gonna bring the 12 A to the second, A, B, C to the second power each, to be like 20. That's why you end up with 4 to the A, B, C. So it says what number can go into 12 and 20?
Yeah,
And you say 4. So when you get 4 now, you're gonna bring it the 4 like the 20.
it's
20
always the greatest common factor now, because the other
Yeah.
numbers will go into 2 goes into them, but it's always the greatest common factor. 4 is the largest number that divides into 12 and also divides into 20.
20. So you use 4. Okay.
That's
okay.
right. Now, then I go to the variables, and I said, always use the variables with the lowest power. And here they're kind of nice
No,
and neat for
that's
you.
the part I don't understand. It when you say go to the variables, that's what I don't understand.
Well, there are 3 variables, A, B, and C.
Okay.
In 12, the powers are 2, 2, 2, almost
2.
A, B, on all the variables, A, B, C. In 20, A is to the 1, B to the 1, C to the 1. So that's the lowest power. So that means my greatest common factor will have A, B, C, because that's my lowest powers on A, B, C.
Okay.
And if I want to check it, take that 4ABC. What do I multiply it to get back my 12? A to the second, B to the second, C to the second. 4 times 3 is 12. ABC times ABC gives you A to the second, B to the second, C to the second. Remember, you add the powers. 1 plus 1, 2. B1
Okay,
plus
okay.
B1, 2. C to the 1, C to the
Oh.
1, 2.
Got you.
And then when I get to 20 ABC, remember I already have my ABC here, so I only need the 5. The 5 times
So
4
4 into
ABC
25.
gives me 20 ABC,
Okay.
right? So this gives me 20 ABC, right? And this one, of course, gives me 12. Let me just do this one. Is equal to 12. And I'll just repeat A to the second, B to the second, C to the second. There we go. I'm just checking it when I get here, right? So what I ask you for, the answer would be for ABC. That would answer that, okay? But this is just a check to see if I take this greatest common factor, can I multiply it by some factor to get back my monomial? And
So, Miss, let me ask a question right there. So, say I get something similar to this, exactly what different numbers. The first thing I'm going to think to start, what number go into 12? I can go into 20 also. That's the
right,
first thing I'm
that's
thinking.
the first step. You want to get the greatest common factor of your constants, the numbers.
Okay.
And then the second step is to get the greatest common factor of the variables. Remember in the rule that the lowest power variable is the one you want to use. And here they kind of neat because they give you 3 variables, all with the number 1 as a power. Because if this had been, say, A to the second, then of course you would have the A to the second. You just have B, C. Okay,
Yeah.
got it?
Okay.
Questions?
More activity on that continually. I think I pick it up faster.
Okay, we'll do one more. Audrey, I want you to do this one. Wait a minute.
Which one is that?
Number 4.
That's all true.
Okay. 22 m to the 5th, n to the 2nd. Let me make it bigger. And I want you to tell me what is the greatest common factor. Okay, this is, all right, here we
11.
go. Okay, the greatest
Mhm.
common factor. Okay, you gave me the number. That's right, 11, because 11 times 22 gives 11 times 2 gives 22, and 11 times 1 is 11. Now, let's work on the variables. You got the number right. Now, what about the variables?
2.
Okay, what about the m?
That is 2.
Okay, let's start with the m.
5.
Which one is the lowest power?
5. 2.
The
5
second.
was is 5. 5 and 2 is 7. Huh?
No. You have m to the 5th and m to the 2nd. Which power is lower?
The 2.
So then you put the 2. All right, now go to the n. You have n to the 2nd, n to the 4th. Which power is lower?
The 2.
So then this will be n to the 2nd. And that would be your greatest common factor.
Oh.
Audrey,
That's
you
it.
got it? That's it.
Yeah.
That's the answer?
That's
Mhm.
it.
That's it. Yeah.
You
it's the
first
second.
look at the numbers. 11 and 22, and Audrey said 11 because 11 goes into 22 2 times, 11
Yeah.
into 1 time. Both of those are prime, so we know the 11 is correct, right?
I will miss right there. Stick a pin right there. I was checking my brain.
Okay.
It's just say you didn't, those two,
That must be the easiest one I
Say-
see.
yes, say 11 could not
That
go
one.
into
Wait,
22. You'd
I'm
have to
just,
get,
okay, Mercedes, what is it?
That is it, 6.
Okay,
Like I said-
Mercedes, what is your question?
I was saying, say 11 could not go into 2. Say we were different numbers, for example.
Okay,
You'd have to find a GCF to go into both numbers, right? And continue.
that's right. The greatest common factor for the two numbers.
Okay, but because 11 can go into 22, you just go ahead and do that and continue.
That's it, because 11 goes into 22 and 11 goes in 11. That's the greatest common factor,
Okay, great.
right?
16, so yes,
Questions?
96.
Other than the numbers themselves, that's really the only factors you have, right? 11 times 2.
Yeah.
Okay,
And then after you get the numbers, the factors for the numbers, these are the coefficients, numbers in front of the variables. Then you look at the variables. Look at the m to the 5th, m to the 2nd. Lowest, m to the 2nd. So you put m to the 2nd. N to the 2nd, n to the 4th. Lowest, n to the 2nd, n to the 2nd. That's your greatest common factor. Got it?
yes,
Now, let's do one more that has 3.
Mhm.
Latoya, are you there?
6, 2, 6.
Latoya,
I don't know if she's in.
Yeah,
Latoya, what's your greatest common factor? We got
12. 12.
Okay, greatest common factor for her numbers is 12. 12
Yeah.
goes into 60, 12 goes into 36,
and
12
then
goes into 24, and
24.
all of them give you prime. 60 over 12 is 5, that's prime. 36 over 12 is 3, that's prime. 24 over 12 is 2, that's prime. Now,
Yeah.
Latoya, what would
Yeah.
your W, what would be your variable?
W2.
W2, very good. Because notice the 2 is the lowest, right?
yes.
And you always pick your lowest power. This should be a small w. Okay, that's your greatest common factor. That's it.
And that is done, miss?
That's it.
Holy cow.
That's it. The other steps you can do it, and that would be 12w to the 2nd times 5w to the 4th, 12w to the 2nd times 3, because that's
Miss-
already w to the 2nd.
You know what I'm understanding with this type of work, that this
Yeah.
new kind of work, it
Go
getting you
keep
to
that
get
code for
your,
yourself.
it getting you to get your multiplication in your head so smartly. That's what I
Yeah,
really,
well, it's getting you to do your mental math, right?
yes.
Mental
Multiplication
math.
is-
There we go.
I
So
mean,
we'll,
Barbara, if you get the greatest common factor, you don't need to put it on all of them, right?
5.
what do you mean under all of them?
Like this one have 3. We need to put the 12W under all 3.
No, no. It
No,
says the
no.
greatest common factor of the monomials.
Yeah, but
Oh,
I'm saying
yeah.
65 into 12
They should-
times 5 is 60.
Yeah, but
And 2
Latoya,
times
Latoya, hold up. A greatest common factor will satisfy each of these monomials. So that
Oops, sorry.
12w square satisfies the 60w to the 6th, 36w to the 2nd, and 24w to the 4th. Now you can go to the next step
Miss.
to prove that they work. The 12w to the
Miss.
2nd times what gives you 60w to the 6th, and what times to give you 36w to the 2nd, and what, but that's like a check. So 12w to the 2nd is the greatest common factor of these 3 monomials. Got it? You don't have to repeat it. Just one greatest common factor that satisfies all 3 monomials. Got it?
Yeah.
Questions, anybody?
No.
Okay,
Thank you, miss.
so I think we have some others here for homework. And I'll probably just give you some more of these. Latoya
You
did
still
her
leave one behind.
factor these polynomials. She did
Still two
those.
more.
Yeah, get all of those right.
Yeah, you got all of those right. That's correct.
Miss Barbara, there's two more, right?
Yeah, you want to do those now or you want to do them as homework? You want to do them now?
Okay.
Just finish them.
Let's just finish them. Okay. Maureen, give me the greatest
boy.
common factor. I heard
That
that,
last week.
Maureen. I heard that. I heard that, Maureen. Greatest common factor. Give me the number first. What number goes in the 105, 30, and 75?
Let's see. 5?
You said 5.
I don't know. That's amazing.
Greatest common factor.
5? No. 6 into 30 is 5.
15.
15?
75.
15 into
15
1.
times 15 times what gives you 105? Who said
15.
15?
15 times,
The 15 times what?
15 times, I think is what? 15 times 7.
That's right. And that's a prime. So that's
Yeah,
okay.
15
What about
7.
30? 15 times what?
2,
2,
2. Another prime. 15 times what for 75?
3.
5.
5. So they all prime. So 15 is your number. That's your correct number for
That's
your
15.
greatest common factor. Now, Audrey, what would be the variable?
Greatest common factor.
What would it be?
Barbara?
What would be the variable?
Yeah.
A. That's right, because A is A to the 1 for all 3. So they equal as far as lowest, right? So it'd just be
Yeah.
15A. That would be your greatest common factor.
And that is done.
That's
We-
it.
Yeah, we finished now.
Well, you
One
got
more.
one
We
more.
do that already.
Yeah, 7 we did.
Yeah, we do that already.
Yeah, 7
Yeah,
Which
we
one?
did. 7 is really,
D12,
Well, I
A,
just-
B, C, yeah.
yeah.
Oh, yes.
7
Oh,
is
yes.
the
You're right.
same.
You're right. You're right.
Yeah.
7 is the
You're right,
same
sorry,
as
sorry.
3.
Sorry.
Maureen, ready to go.
No, I'm ready to go back.
Maureen.
I know we do that already. Wait to do it again.
Yeah, you're right.
Oh,
We
she
did
was
that.
sorry, like me.
7 is
That's
the
okay.
same as, so what's the answer, Maureen?
Okay.
What's the
Huh?
greatest common factor? You say we did it already. What's the greatest common factor?
Uh-oh.
Maureen,
But we
what is it?
do it.
What is the greatest common factor, Maureen?
Uh-oh.
Come on, Maureen. Come on.
What is it? What is it, Maureen?
4
For
ABC.
what,
Of
Maureen?
course. 33.
I asked
ABC.
Maureen, what is the greatest common factor?
It's Bible 4.
For what? Remember, you have to give me a number and variables.
We do it here just no, man. 4
Well, you say we did it, so what is it?
4 A, B, C.
That's
Yes.
it, Maureen.
Yeah, because
Very
the
good.
ABC
Very
Maureen.
good,
Comes one,
Maureen.
yeah.
For
Yeah.
ABC. Okay.
Very
All
good.
right. So we'll stop here.
Maureen is funny.
And
I got good memory now.